Hi everyone, and welcome to Transportation Network Linear Programming Problem. And for this problem, we are supposed to minimize the number of bushel miles the fruit must be shipped. Remember, this is part of the optimization problems that we've been dealing with. And so we need to find out how the company can reduce or can minimize the number of bushel miles that the fruit must be shipped to cut down costs as much as possible. So if you look at this question, you can see that first of all, the company has different sources of the raw materials, and these are from Mount Dora, Eustis, and Claremont. And you can see that from Mount Dora, the amount available, 275,000 bushels. Eustis, they have 400,000, and Claremont, they have 300,000. So those are the amounts or the resources which they have from their sources, three of them. Now, the company has processing plants in different locations also, and these are Ocala, Orlando, and Leesburg. And if we look at the capacity for Ocala, it is only 200,000. For Orlando, is 600,000, and for Leesburg is 225,000 bushels. So what the company has to do is to supply to processing centers amount which should not exceed their capacity, but also make sure that the amount which they have, all of these products should be shipped, otherwise they will rot. These are fruits. So how the company will be able to transport their inputs to the processing center. And so here we are given the distance between the groves and the plants. Here we have Mount Dora. These are the groves. So we have Mount Dora, Eustis, and Claremont. Those are the sources of the inputs. And we have the total distance from the source to the processing plants. So we can see from Mount Dora, we have 21 bushel miles. Orlando, they have 50, and Leesburg, 40. And so for Eustis, the miles to Ocala is 35, to Orlando 30, and to Leesburg 22. And Claremont, the distance is 55 miles to Ocala, 20 to Orlando, and 25 to Leesburg. So how can this company minimize the total number of bushel miles the fruit must be shipped? We can actually look at this problem and try to solve it without using solver. For instance, you can see that from Mount Dora to Ocala, the distance is the shortest because Orlando is 50 and Leesburg is 40. So intuitively, we could say that most of the inputs from Mount Dora should be shipped to Ocala if Ocala has the capacity to take all or a big part of the inputs from Mount Dora. Because you can see Mount Dora's distance to Ocala is actually the shortest as compared to Eustis and Claremont's distance. It is actually very far from Claremont. And so I would say a big part of the inputs should come from Mount Dora to Ocala. And we are told that Mount Dora has 275,000 bushels, while Ocala requires 200,000. So what I would say is we could ship 200,000 of the bushels from Mount Dora to Ocala, and then we fulfill the demand at Ocala or the capacity that Ocala can receive, but still we have 75,000. And I would prefer to ship the 75,000 to Leesburg instead of Orlando because it's a little far. So Leesburg is at least a little better. And so 75,000 could go to Leesburg. I will assume to do so. Now, if you look at the Eustis distance to Ocala, 35 is more than 21. So, and already we have covered here. So, but you can see Eustis to Leesburg is shorter. It is the shortest actually as compared to Mount Dora and Claremont. But here we have received 75,000, and so the remaining part should come from Eustis. In this case, we know that Eustis has 400,000, and the amount that is needed at Leesburg is 225,000, and so 225,000 minus 75,000, and so the remaining part should come from Eustis. But still, we may have more of the amount from Eustis, which is 400, and so that can be either sent to Orlando, not to Ocala, as compared to Orlando. And so for Claremont, we could ship the big amount to Orlando if at all Orlando capacity will allow us to ship there. And so Orlando will receive from Eustis and Claremont, and also the remaining part, if there is any, will go to Leesburg if Leesburg's capacity is not fully covered. So you can see this kind of question requires a lot of thinking, a lot of moving variables here and there until when you are able to make a good decision of shipping this product. However, we can make this easier by creating a model and then use Solver to solve the problem to minimize the total number of bushel miles that the fruits must be shipped. And so all we're going to do now is to create the model. So we are going to start by creating network that will simplify our model, and just go to the insert and shapes. You can select any shape you want, but I would like to use this shape, and so I'm going to create the shape here. And so I'm going to use this as a node, and I'll write this Mount Dora, because I'm going to start with the source. The first source is Mount Dora, as we have said, and we are going to ship, I think, to 75,000 number of inputs. That's one. Now I'm going to duplicate this so I can make three sources of the inputs, and all I'm going to do is to put the mouse here and then hold down Control and then drag this down, so you can copy this, and then I'm going to do the same. Just put the mouse here and then hold down Control key and drag this down, so you get 1, 2, 3. So I'm going to change from Mount Dora. I think we have, let me see, we have Mount Dora, we have Eustis, and also we have Claremont. So here we have Eustis, and we have Claremont. So let me put the amount that has to be shipped from Eustis and Claremont. So this is the second, and that is the third. So from Eustis we have 400,000, and Claremont 300,000. So here we have 400,000, and also here we have 300,000. So those are the sources of our inputs. Now let's show the destinations or the processing plant. And so I'm going to hold down Control key and copy this to the other side. And also I'm going to copy the same, because we have 3 different locations or processing centers, and so those are the ones. And here we have Ocala, and then we have Orlando, and the last one I think it's Leesburg. So let's see how much is required at Ocala. So you can see Ocala requires 200,000, Orlando 600,000, and Leesburg 225,000. So I'm going to change here to 200,000, and this should be number 4. And Orlando, they need 600,000, and that is number 5. And Leesburg is 225,000. Let me make this number 6. And so we can create the network. So I'm going to go to the insert, and I'll go to, I'm going to use the arrow. So let me click this, and I'm going to show how we can move our the inputs. So we can move inputs from Mount Dora to Ocala. But at the same time, we can move inputs from Mount Dora to Orlando. That is possible. Let me copy this. Or we can move our products from Mount Dora to Leesburg. So those are the three options we have by shipping products from Mount Dora to Ocala, to Orlando, or to Leesburg. But at the same time, we can also move our products from Eustis to Orlando, to Ocala. But we can as well move or ship the products from Eustis to Orlando. But also, we can move these products from Eustis to Leesburg. So we have those three options. And then let's go with the Claremont. In this case, we can ship products from Claremont to Ocala. That is possible. Or from Claremont to Orlando. And also, we can ship from Claremont to Leesburg. So you can see that we have we have three options of moving inputs from Mount Dora, Eustis, and also from Claremont. Let's now try to see the total miles that can be covered. I'm going to click on the insert, and also I will select the shape. We are looking at the distance from Mount Dora to Ocala, and the distance from Mount Dora to Ocala is 21 bushel miles. And so I'm going to write 21. I'm going to hold down Control key, copy it to this line here, and I will change from 21 to the miles from Mount Dora to Orlando. It is 50. And so I'm going to change this to 50. And I'm going to copy this as well. Hold down Control key, copy it down here. And I'm going to change this to 40 from Mount Dora to Leesburg. And so I will just keep copying this so we can see the distance from Mount Dora to Ocala is 21. Mount Dora to Orlando is 50. And Mount Dora to Leesburg is 40 bushel miles. And then from Eustis, 35 miles to Ocala. It is 32 miles to Leesburg, and also it is 30 bushel miles to Orlando. And so for Claremont, we can see 55 miles to Ocala, 20 miles to Orlando, and 22 miles to Leesburg. And you can see that we have constraints, the amount which is available at Mount Dora, what is also available at Eustis, and the same with Claremont. And we can see the capacity that is needed at Ocala, which is 200,000, 600,000 to Orlando, and 225,000 to Leesburg. You can see that here we have 1, 2, and 3. Those are the sources, and we have the destinations, which are 4, 5, and 6. So just to define the variables, and so we're going to have X, I, and J, meaning that the sources are I's and the destinations are J. So we have Xij, meaning that you can ship from Mount Dora to Ocala. That's Xij, and I is 1 and J is 4. Or if from Eustis to, let's say, to Leesburg, then we have Xi, which is 2, and J, which is 6. So In this case, we can actually define the decision variables. So based off this network and what we have defined here, now let's go and create our model, or we can say mathematical. Let's start with the mathematical model. And in this case, we are going to start by looking at the decision variables. So how many decision variables do we have here? If you can see, as we have said, we are going to look at decisions that we are making based off the distance or from the sources to the processing center. And so you can see that we can ship from Mount Dora to Ocala, but also we can make a decision to ship from Mount Dora to Orlando and also to Leesburg. The same with Eustis, you can also we can ship to Ocala, Orlando, and Leesburg. And with Claremont, we can also ship to Ocala, Orlando, and Leesburg. And so we're going to use this Xij to define the number of decision variables. And so here we have the first one, which is x14, meaning that we are moving from 1 to 4. That means we are moving from Mount Dora to Ocala. So that's x14. So I think I made some mistakes here, and so let me do some changes. This is supposed to be 25. And this is not 32, it's supposed to be 22. Okay, so now let's go back here. We are going to define our decisions. And so Xij, let me write here first. Xij will show the number of bushels to ship from, so we have this node, and so I'm going to say from node I to node J. From node I to node J. So I will be 1, 2, 3, and J will be 4, 5, 6. So now we can define our variables. So we're going to start with x14. And in this case, you can see that it shows the number of bushels to ship from Mount Dora to Ocala. So let me write here. So that's the number of bushels to move from Mount Dora to Ocala. And here we can have x15. So that's x15. So, and this one is the number, let me copy this, is the number of bushels to ship from Mount Dora to Orlando. And so we have also x1 and 6. What x1, 6, meaning that we are moving from Mount Dora, which is 1, and 6, which is Leesburg. And so I'll do the same copy and paste here. And that will be the number of bushels to ship from Mount Dora to Leesburg. And then we are done with the first 3 sets of decisions. And so let's go with the second one, which is from Eustis to Ocala to Orlando and also to Leesburg. And so that will be x24. And let me copy this. That will be the number of bushels shipped not from Mount Dora but from Eustis to Ocala. And so we have x25, x25. That means the number of bushels to ship from Eustis to Orlando. So let me copy this also and paste here. So that will be not to Ocala but to Orlando. And then we have x26. So that will be the number of bushels to ship from Eustis, which is 2, to Leesburg, which is 6. So let me post here and type here Leesburg. That is the second set of decisions, and that will base on Eustis. Now let's go with the last one, which is X3, 4. Here we have Claremont, which is 3, and 4, which is Ocala. And that will show the amount of bushels to ship from Claremont to Ocala. And then we have X3, 5, X3, and 5. So the amount of bushels to move from Claremont to Orlando. So I'm going to copy this and paste, and then finally we have we have X3, 6. So here we have X3, I is 3, and J is 6. So that is the amount to be shipped from Claremont to Leesburg. So let's see how many variables do we have. So we have about 9 decision variables. We call these decision variables because we're going to make decisions of the number of bushels to ship from I to J. The second thing we're going to do is to define our objective. After we know the decision variables, so we need to look for the objective function. Objective function here is to minimize cost. And so we're going to type minimize. We're going to minimize the bushel miles. So we're going to minimize the distance. And you can see that we have all these miles, and so that's what we're going to do. And in this case, we are going to minimize the distance from Mount Dora to Ocala. But in this case, we know that the mile is 21. So in this case, if you do one trip, then you will go 21 miles. If you go twice, then it will be 21 times 2. And so this variable will be changing. And so that is one. We want to minimize the total distance from Mount Dora to Ocala, and also from Mount Dora to Orlando. Mount Dora to Orlando, which is 50. And so here we're going to type 50 x15 plus, here we have 40, and so it will be 40 x16. So those are the miles to Ocala, 21, to Orlando, 50, and to Leesburg, 40, and that is from Mount Dora. And in this case, all we're going to do is to try to minimize that total distance. But still we have distance from Eustis to Ocala, Orlando, and Leesburg. And so we're going to add that for Eustis, and that will be, if you can see here, Eustis to Ocala is 35. And so we have 35 x24, x24. And so you can see x24, and the distance here is 35. We're going to add 30 x25, and here we have 30 to 5. The distance is 30. So we're going to add again the distance from Eustis to Leesburg, and that is 22. This one here, and so 22 x25, x26, sorry. And then we're going to add more for from the distance from Claremont to Ocala, and also to Orlando and to Leesburg. And you can see we have the miles. From Claremont to Ocala is 55. Claremont to Orlando is 20, and Claremont to Leesburg is 25. And so we're going to add those distance, and here we have 55 x 3, 4, 3, and 4 plus 20 x 3, 5, this 20 here, the distance from Claremont to Orlando, and we're going to add the Claremont to Leesburg, which is 25, and so we have 25 x 3, 6. And so in this case, we have created our objective function, meaning that we want to minimize cost, or we want to minimize the total bushel miles from the sources to the processing centers. And so that's the equation we have created. And now the next thing we have to do is to look at the constraints. Let me write here constraints. So in this case, we have a number of constraints. So let's see 3.1 constraint, and so we will go back here to see what are our limits, and you can see that our first limit will be the amount that is available from the sources. And so you can see at Mount Dora, we are limited by 275,000 bushels. And Eustis, we are limited by 400,000 bushels. And Claremont, we are limited by 300,000 bushels. We cannot get more than that. That's the amount which is available. So that's our first limit. The second limit will be the capacity, how much the processing centers can receive. And you can see Ocala can only receive 200,000. Orlando can receive 600,000, and Leesburg can only receive 225,000. So those are the limitations. So we have the first set of limits and the second set of limits. But also we have the third type of limit, which is non-negativity condition, meaning that we can either ship or we may not ship the amount. We cannot ship the negative. So there is no negative amount which has been shipped. And so that is important decision. So let's write the first set of decision, the first set of constraint. So this one will be availability of resources. And so the availability in this case will be the amount that is available at Mount Dora to Ocala plus the amount that is available from Mount Dora to Orlando plus the amount that is available from Mount Dora to Leesburg. So this is 275,000. That's the available or the availability of inputs from Mount Dora right here. But let's see also the amount which is available from Eustis. So we have x2, 4. That is the amount which we can take from Eustis to Ocala. And the amount that we can get from Eustis to Orlando plus the amount that is available from Eustis to Leesburg. So that will be x2 and 6. And so that means you can ship from Eustis to Ocala, Orlando, and Leesburg, but you are limited by 400,000 bushels. And so that is the availability from Eustis. Now let's go with the last one, which is the amount which is available from Claremont to all these three centers. And so we have x34 plus x35 plus x36, and we have only 300,000. And so that is the availability. That's the availability from Claremont. In other words, we are trying to say that we have 300,000 bushels at Claremont, and we need to ship this from Claremont to Ocala, to Orlando, and to Leesburg. And also, we have 400,000 available at Eustis, and we need to ship this to Ocala, Orlando, and Leesburg. And also, we have 275, which is available at Mount Eudora, and we need to ship this from Mount Eudora to Ocala and also to Orlando and Leesburg. We cannot ship more than this. This is the only amount that is available. And that is our first set of constraints. So let's look at the second set of constraints. We are going to look at the capacity. And this capacity is what Ocala can receive from Mount Eudora, and what Ocala can receive from Eustis, and what Ocala can receive from Claremont. And so the same with Orlando and Leesburg. And so we can write this constraint as follows. We can say x14 plus x24 plus x34. That means we can ship from Mount Eudora to Ocala. We can also ship from Eustis to Ocala and from Claremont to Ocala. But Ocala can only receive, or its capacity is 200,000. So in this case, we can ship the same or less amount. We can receive 200,000, which is the capacity, or we can receive less than the capacity. So that is 200,000. And in this case, we are looking at the capacity restrictions for Ocala. So let's see the capacity restrictions for Orlando. And so in this case, we can receive inputs from Mount Eudora, x15 plus x25 plus x35. That means we can get products from Mount Eudora to Orlando, or from Eustis to Orlando, and also from Claremont to Orlando. And Orlando, we know that the capacity is 600,000. So we can receive the same amount or less amount, which is 6,000. And that is the capacity for Orlando. And finally, we are going to see the capacity for Leesburg. And so we have x16 plus x26 plus x36. So that means we can ship from Mount Eudora to Leesburg, from Eustis to Leesburg, and also from Claremont to Leesburg. And the capacity for Leesburg is 225,000. So Leesburg can only receive the maximum of 225,000 or less. So 225,000, and that is the capacity restriction for Leesburg. So that is the second set of constraint, and let's look at the last set of constraint, which is the non-condition. Remember, this condition is very important. And so this condition we can say xij, meaning that we can ship from any source to any destination, or we may not ship. And so that should be greater or equal to 0. So in this case, you can see that we have actually created our mathematical model. We have our objective function, and also we have these three sets of constraints. And having this, then it's easier for us to create the model that we can use Solver to show how we can minimize the bushel miles from the source to the destinations. So let's create the model so that we can use Solver to optimize. So let me write the name of a company, ABC Company. Here we have Tropic Sun, but I'm going to use a different company, ABC Company. And in this case, the first thing that I'm going to identify here is the distance from the groves to the plant. So let me write here, distance to plants. And so in this case, we have groves and we have Ocala, we have Orlando, and also we have Leesburg. Those are the destinations. And so the groves here, we have Mount Dora, and then we have Eustis, and we have Clarimont. So we're going to see the distance from Mount Dora to Ocala, Mount Dora to Orlando, and Mount Dora to Leesburg. So the distance are defined here. Mount Dora to Ocala is 21. Mount Dora to Orlando is 50. Mount Dora to Leesburg is 40. So let me put them in here. So we have 21, and we have 50, and also we have 40. And the distance from Eustis to Ocala was 35, and the distance from Eustis to Orlando is 30, and also to Leesburg is 22. And the distance from Clarimont to Ocala is 55, to Orlando is 20, and to Leesburg is 25. So that is the distance covered. So now let's look at the bushels shipped. So in this case, we have bushels shipped from groves to plants. And I'm going to copy this, but not the values. So just here, but I'm going to remove the values. So in this case, we're going to look at the bushels that should be shipped from groves to plants. We haven't made any decision yet. So in this case, we can select any value. So let's go with the zeros, meaning that this will be the changing variables. So because we haven't made any decision yet, we don't know how much we're going to move from Mount Dora to Ocala. And so put all zeros, and let me highlight this in yellow, and I'm going to define the yellow color as changing variables. And so in this case, we have we can look at the total amount which is shipped. So we have the amount that is shipped from Mount Dora to Ocala, Orlando, and Leesburg. And so how much of the bushels that have been shipped from Mount Dora, from Eustis, and also from Claremont. So here we can say bushels shipped. So we can know how much we ship if we can add the total amount that has been shipped from the source to different destinations. So we can put equal sign here and type sum, put equal sign, type summation, and so select sum and select all these values, close the bracket and enter. So now we have zero amount of bushels that have been shipped from Mount Dora to the three destinations. So try to change a value here. If let's say we ship 1, you can see that this will change because we have created the function, and that function is sum. And so we can copy this function if you put your mouse there and drag down. So you can see that for Eustace, we haven't shipped anything, and so the sum of the bushels that are shipped from Eustace is 0, and also Claremont is 0. And so even if you put 0 there, that will also show that the bushels shipped will be all zeros for now. Now we need to put our limit because we know there is a limit there, and that is the bushels available. That is the amount of bushels that is available from Mount Dora, from Eustace, and Claremont. So in this case, if you can remember, we had 275,000 from Mount Dora, and then we had 400,000 from Eustace, and also we have 300,000 from Claremont. And so what is the limit here? The limit is we have to ship all this amount. And so the amount that is going to be shipped from Mount Dora to any of these locations, it should be equal to the bushel available. So the total bushels shipped from Mount Dora should be this amount. We don't want to leave anything behind because they can rot. So this is our limit. But also we can see the amount received. How much Ocala received from Mount Dora, from Eustace, and also from Claremont. So I can say here, amount received. And so to find the amount received, we are going to also sum these amounts, or anything that comes from Mount Dora, Eustace, and Claremont. So I'll type the function which is summation or sum, and I will select those three and enter. And you can see at this moment we are not receiving anything because there is nothing that is shipped, but we can copy this function up to this point to see how much is received at Ocala, Orlando, and Leesburg. But we also have limitation. Let me write here limit. And the limitation which we have here depends on the capacity. So the capacity for Ocala, if you can remember, it was 200,000, and for Orlando, it is 600,000, and also for Leesburg, it is 225,000. So that's the capacity which these centers can only receive. So we can ship this amount to Ocala or less. So in this case, we're going to put less or equal to this capacity. And we'll do the same for Orlando and also for Leesburg. Now, finally, we need to find the total distance in bushel miles. If we ship anything, what will be the total distance covered? So let me write here the total distance, and this is in bushel miles. And we can get it here, and let me put a different color. That will be, I'm going to use this color. And in this case, I will need to define that color here. And so this one will be our set cell, or the objective. So then how do we find this total distance covered? The total distance covered will be the amount that has been shipped per day miles, the distance from the sources to the destination. So in order for us to do so, we can use Excel function, and so put equal sign, type sum product, and the sum product will be of the total miles. You then put the comma sign times the amount that is shipped from different sources to different locations, and so you can close the bracket. Now you can see we have selected the miles and also the bushels shipped from the groves to plants, and then you can enter. Now you can see we haven't shipped anything, and therefore there is no any miles covered so far. So assume that you can ship 10, just put 10 there. You can see the miles covered from Eustis to Orlando. Here we have Eustis to Orlando. If we are shipping 10, then that will be 10 times 30, and that will be 300. And so now you can know that our function is clear. So having done this, we can now use Solver to minimize the number, to minimize bushel miles covered when we are shipping all this. What it means is we are going to see what should be shipped from which grove to which plant in a way that we will minimize the miles covered or the distance. So we can do so by using Solver. I'm using Mac, and I need to go to the tools. You can see tools on the top, and then I'll go to the Excel add-ins. And with Excel add-ins, I'm going to select Solver add-in, and then I'm going to click OK. So in this case, if you click on the data, then you can see we have Solver, and therefore let me select the Solver. And the first thing I'm going to do is to select the set objective, and if you can remember, the set cell is this color, and that's the miles covered. So I'm going to click on this cell, and here you can see two: either maximize, minimize, or get a value. So we will see what decision should we make here. And if you can go to objective function, you can see we are supposed to minimize, and therefore we will select minimizing, and then we are going to see which variables should we change. And so you can see the changing variables will be the yellow colored cells, meaning that we are going to change the amount which will be shipped from the groves to the processing plants. And so in this case, I'm going to select all this. But we have to add constraints. So we have our constraints as we did before. We have three sets of constraints. One is the availability, and the second one is the capacity, and the last one is the non-negativity condition. Let me start with the non-negativity condition, which says any amount that has to be shipped will either be shipped or will not, but we cannot have the negative of it. So I will select all these goods which will be shipped and change this to show that we can ship or we will not ship. So it should be greater or equal to 0. And then I'm going to add another constraint, which is the first set of constraint that is availability, meaning that we need to ship what is available from all the sources. And so in this case, you will see that we have created this limit, and so the bushels which will be shipped should be equal to their corresponding bushels available. So I will select this 3, and I will change the sign here to be equal, and then I have to select all these 3 constraints. Remember, all I did was the bushels shipped equal to the bushels available. Now let me add the third constraint, and it is this one here. The bushels received should be equal or less than the capacity. And so in this case, I will select the bushels received, and I'm going to maintain this sign here, which is less or equal to the capacity. I'm going to select the capacity here, and then those are the 3 constraints which we have. I don't have to add any other constraint, and so I'm going to click OK. And so you can see that we have our constraints, we have the changing variables, we have the set objective, and all we have to do is to minimize. Then I have to make unconstrained variables non-negative, so you have to select this. But also we're going to change the algorithm from GRC from GRG to simplex method, and then you can solve. You should get the solution which says all constraints and optimality conditions are satisfied. If they are not, then that means your solution is wrong. You have to find where you made some mistakes, correct the mistakes to get the right solutions. And so I'll click OK to see what we have here. You can see exactly the same as what we said before, that it is economical to ship all 200,000 amount of bushels needed at Ocala from Mount Dora because of the distance, which is the shortest. And so once you receive that, you don't have to ship anything from Mount Dora to Orlando because it's expensive. And the remaining 75,000, you should ship it to Leesburg. So use this to Ocala and Claremont to Ocala. You don't have to ship anything because already we have shipped 200,000. So what we're going to do for Orlando, you can see that the distance from Claremont to Orlando is actually the shortest. And that means we'll see how much we have from Claremont. We have 300,000 which can be shipped to Orlando. So we have exhausted the amount which is available at Claremont. And that's why we don't ship anything to Ocala and also to Leesburg. But remember here we know that Eustis to Leesburg, the distance is 22, and therefore we will ship the remaining amount, which is 150, to make 225,000. So what is remaining from Eustis should be shipped to Orlando. And so Orlando will receive 250 from Eustis and also 300,000 that is available at Claremont. And we have exhausted the amount to ship. And you can see that in this case, Orlando will only receive 5,000 and 550,000, and we will not get we're getting less of the 50,000 bushels, but that is okay because we can receive to the maximum or to the capacity or less. But Ocala will receive 200,000, and also Leesburg will receive 225, and that is the best solution. And in this case, the total distance in bushel miles covered will be 24 million bushel miles. And so that is the best decision that this company can make to ship inputs from the groves to the plants. So all I need you guys to do is just to provide a short description of the results that you've gotten, and that's all. Thank you.